Okay.
Uh,
So basically, one of the books that I was just talking about, it's the book Automated Machine Learning Methods, Systems and Challenges. And what I figured in the Netherlands, students hate to buy books. Even if I say you need to teach, you need to learn this book, buy the book and learn it for the test, they will say, can we also learn it from slides? This book is freely available on automl.org. I will add it here. So that might be a reason for students actually to dive into the material without even having to rely on publicly available slides or slides provided by the teacher. And as I mentioned before, part one here is really what I think should be focused on. But part two and part three, they are also okay, even though. Yeah, given that there's probably only one or two lessons on automated machine learning, this would be too much. And then there was another book that actually is a little bit of a shameless self-promotion. I also put the disclaimer here. But currently, regarding transfer learning, I couldn't find an appropriate book. And later this year, the book on meta-learning applications to automated machine learning and data mining will be released. This has an excellent chapter written by Ricardo Vilalta on transfer learning. And currently also one of my students is, even though the publisher is pushing us to hand over the manuscript already 2 months ago, one of my students is currently writing a second chapter on this. This book is not freely available, but I do have some contact with the how do you call it, with Springer, and some of the chapters can be made publicly available. So this is something that I could actually help with, and this is content that I really stand behind. I think this is going to be a great resource, even though it is not out yet, and it's also not freely available yet. But I think that's one of the things that well, at least for this part of the book, we can help get that arranged. Yeah, any comments on this? Because who of you are actually going to give this course, except for Matt? Are there any other people that are actually planning or scheduled to give this course? Then let's continue. So looking at the outline of the course that was being delivered, I think in Athens 2019. This is what was being provided, and personally, well, I think there's a almost one-on-one match with between what is in the deep learning book by Goodfellow et al. And this outline. Except that I was myself very surprised. First of all, well, if you look at the chapter numbers, they are kind of all over the map. So how do you say? It's not really chronological. And also in the deep learning book, they start with actually some very complicated how do you say, mathematical background. So linear algebra, something that students really should have confidence with applying this. And there are some other concepts that the book starts with. Yeah, so the dangerous part of this book is, I know there are easier books on deep learning, and I think even in Leiden, the person that gives the deep learning course does not use the deep learning book by Goodfellow. When I was at Freiburg University, I was lucky enough that my back then professor Frank Hutter did use this book, and in that year we went actually chronologically through the book. So basically, the original outline is shown as this, and again, I would not propose to change anything about this. However, I would, if I were to give the course, I would swap some lectures around, and also start with some kind of overview or recap. So the chapters 2 to 6, as you can see in the previous outline that was made in in November 2019, there was nothing mentioned about topics that were regarding the first 6 chapters. The first 5 are really introduction. The 6th chapter is only the 6th chapter is the first time that the mention is being made of deep learning. So of actually least of neural networks, and kind of I think the outline that was being provided from Athens 2019 assumes this as prior knowledge, and I think that that is totally fair. This is kind of what we did also when we gave this course back in 2017. And at that moment, there was just one lecture where one of my colleagues, another postdoc, went through the first 6 chapters in super fast speed, and basically there wasn't even time for questions. And if students had questions, they were referred to Khan Academy instead of asking them during the course. But basically, when you rearrange the lectures a little bit, you come towards something that really nicely follows the book of the deep learning guys. And interestingly enough, I was actually surprised that they also actually have a chapter on automated machine learning, or how to tune the hyperparameters of a neural network. I should immediately add the content is not as rich and not as state-of-the-art as the things that you will find in the work that is being done by Frank Hatter, Joaquin van Schoren in the other freely available AutoML book. But yeah, this is of course something that people that give the course can choose themselves if they want to go for stay with the book, which seems like something, even as an automated machine learning person, I would probably do to make it easy for the students, or have a little side track here for work that that comes from a different book and might not have a specific focus on deep learning, but is interesting enough in itself. Then the only problem that I found was that for transfer learning, there's not really a book yet. So therefore, this led me to add this shameless self-promotion here in this schedule. The meta learning book to appear later this year will have two chapters on this this topic. And if not, maybe someone gives this course already in the fall, or maybe someone thinks 3 books that is way too much. The survey paper by Hospedales that came out earlier this year, I think this is really excellent stuff, except that he doesn't really go into detail. So this might be good material for students to study, but they will absolutely not be able to implement after reading this paper, is what I found. But it's a good starting point to get to relevant recent literature parts. And basically, what I did when assembling the slides, I was actually very surprised that this was a task, because most of the slides, they are available on the deep learning book website. I know that these are not the best slides that one could eventually end up with, but I think this is a good starting point for teachers to start with. Also, Matt made me aware that he has some additional slides made available also in the shared space. Matt, can you maybe spend a few words on this?
Yeah, sure. So as I said, the way I see this course is mostly students reading papers and then having discussion in the class. But you got to have some background in the topics before you can understand the papers, right? So what I did this time is the first time I taught this course. So we went through chapter 9 of the Goodfellow book. And so I basically gave a couple hours of lecture from that chapter, and then we dove into the papers on CNNs after that, and then same thing with RNNs. So we I think it's got a really nice coverage. The book's got a really nice coverage of the fundamentals of RNNs, and then LSTMs and GRUs and so on. So we give a lecture based on that, and then we move to papers and discussion after that. So it was a good experience. only the really dedicated students took the class, and so, but then they were really dedicated. So, so we had a lot of fun with it. These are computer science students, not data science students. So, I don't know if we'll have the same experience next year when we teach it with the real, as part of the Erasmus course. But yeah, it was good.
So the course outline that you just mentioned, I really like this, and I actually, when I gave my first master course 1 year ago, I envisioned to have exactly this setup, a little bit more where students were also required to give a presentation, and yeah, hopefully a lot of discussion after a presentation from students. But then in the first lecture, well, more than 100 students showed up, and well, there wasn't a panic, but well, I had to put off some very annoying tricks to at least tease some away, and eventually I was left with 60 students. With 60 students, I found it impossible myself to host a discussion, and it was basically students gave a presentation, and afterwards I went into discussion with the. I tried to you know, encourage the people from the audience to also engage in the discussion, but if you're lucky, one person dares to ask a question somehow. So I think that the setup that you mentioned, this is absolutely the preferred setup. However, it probably doesn't really scale to larger groups, and also to groups when the yeah, the students. I always think there are two types of students: students that really want to, you know, learn, and they want to become good at something, and there are students that want to get their grade, and they want eventually to have their master degree. And if the room is dominated by the first type of students, well, I think there's a lot of things you can do and have an amazing course with this. If the room is dominated with the second part of students, I think that yeah, that sticking to the book and actually sticking also to lectures, this is the way to go. Yeah, and of course teachers have to make their own assessment in what is well, what are they going to expect from the students. And I myself have no answer how to make such an assessment before a course starts, actually.
Well, I guess one thing is this course is a second semester course. So after, you know, when we start this course, we'll already know the students from the previous semester. So yeah, we kind of know. I fully agree with your assessment of the two main types of students. That
We lost you for a second, Matt, but you're back now.
I didn't get dropped completely. Yeah, we have a storm and the power just went out, but okay. Somehow the network didn't go down. That's amazing. Okay. Yeah, sorry. Anyway, yeah, I was just gonna say that I agree with your grouping of students. It's true. And yeah, so in this course, I think because it's elective, right, then it's gonna tend to be the ones that are really, really interested. So that's okay. Good. And I don't think any of us will have 60 students in any class in this program. Okay. I'm not sure.
That's good for for you. I wish that I could give my course with a relatively small and motivated group. But yeah, good. And then, well, there's one more thing that I wanted to discuss here publicly, and so far, all that I did was of course point to some slides that everyone already knew were online, and some books that were already picked out. But this is something that I well want to point out, that I really added something, and I hope that it will actually help something. So when we were giving the course in Freiburg, I was partly together with my colleagues Matthias Feurer. Forgot one of my colleagues' first name, but Gargiana, Stefan Faulkner, and Frank was doing the lectures, and we were basically in charge of the exercises. And what Frank did really nicely, he asked every week one of us to make a Python notebook where the students basically were given away most of the things that they had to do, but still they had to fill in some things, and students were kind of required to hand in the notebooks. We didn't really have a large review procedure on this. Also in Freiburg, we wanted to keep the course small, but still a lot of students showed up, if I recall. So we didn't really check it. We just checked if you know, the students could run the notebook and no errors came up. And actually, I was able to find the exercises that I made myself back in those days, which does not cover the complete book. This just covers several of the chapters of the book. But I could add that if people think this is useful, mostly as, of course, as something to inspire people, because also exercises should be, of course, changed, adapted to maybe new standards and new versions of. I think these chapters never used any specific neural network library, but of course they should be adapted every year a little bit. But if those exercises are deemed useful, I could actually reach out to my own student, my old colleagues, and ask if I can also make available the exercises that were not created by me myself, but I feel like I have some authorship over this, because I also reviewed them, and you know, I helped the students do them, and I gave feedback on it. So I think that I have some how do you say, yeah, at least some right to ask them to also hand out the other exercises that we made. And that is actually a series of 8 exercises in total then, starting with chapter 1 in the book and going chronologically until chapter X. I don't remember, but I think we stopped after part 2 of the book because time was up. So what do you think? Well, maybe it's good to have a look at the exercises, and I would also be very interested to have some feedback if this is useful. And
yeah, the first 2 I think are covered in the first course, actually, machine learning. But then, yeah, but I think all 3 of them should be very useful.
I think chapter 7 was part of the course outline. Well, regularization of course covered in machine learning itself, but if I'm not mistaken, let me see what topics.
Oh, yeah, there's a dropout and so on section, right? Yeah, you're right. Yeah.
Hello, may I ask a question?
Yeah, sure.
Yeah, it related with the, I mean, with overlap with the machine learning course. I mean, like in the natural noise processing, the state-of-the-art technique now is using the LSTM attention. So in the time series 1, right? And then in the future, I think that the state-of-the-art is perhaps in using convolutional neural networks, right? So I don't know. When is the naturalized processing and vision is taught? It is in the 2nd semester. If it's in the 2nd semester, then it will be in the same semester with this recent trend in machine learning. Because I thought that perhaps the students should know first about this CNN and RNN LSTM. Then after that, they take the NLP or vision.
But sorry, I didn't. The connection was a little bit. Can you reformulate the question?
Okay. So so the NLP, because I understand the NLP one. The NLP, the state of the art is using the RNN, right? The LSTM and so on. So I thought that they should understand first this the one that you write before, the time series learning, before they take the NLP. So if this course is in the 2nd semester, then the NLP should be in the 3rd semester, or can it be done in the same semester, or perhaps the basic of the RNN is being taught in the machine learning course? What do you think?
So I do not know too much about the NLP course, but I can comment, of course, back to the way that we teach the master courses in Leiden. And in Leiden, there's actually a surprising larger amount of overlap between courses, between topics than you actually might expect. So NLP, I can completely imagine that that you need to have knowledge about LSTMs in that course. And that is, yes, that is being taught in this course. Chapter 10 on the deep learning book covers this, if I'm not mistaken. However, if the courses were to be swapped around, if you get first the LSTM course and then the recent trends in machine learning course, I can kind of imagine that, of course, LSTMs should also be explained in that course. And the fact that there's overlap and that you already touched upon one of the subjects in another course, I think that's only good for the understanding of the students to get the slides from two different perspectives, of course, if the teacher is a different teacher as well. At least that's the first thing that comes into my head based upon your question. Maybe someone else also has an opinion on this.
Yeah, because last night we discussed about this NLP. There's so many subjects in it, so of course we cannot teach the RNN inside the NLP course because there will be too many. So we imagine that the RNN be taught in this course or in the machine learning part.
Yeah, I guess I would comment that I think that I mean, at least we would have some students that are interested in language and are not interested in vision, right? And so for those students, I think they would want to skip this deep learning course, right? But then of course they would want to pick up the necessary elements that they need to do state-of-the-art work in their area, right? So they would have to come back to the RNNs, right? But yeah, I bet I bet they'd be happy to skip CNNs and all that stuff. So and you know, all these vision models like detection and segmentation and stuff, they don't want that, I think. So I would think that that you should cover it. Go ahead and cover it twice. It's not harmful.
Okay.
It might actually also, for the person teaching the NLP course, it might actually even be, you know, there are two things that you can do. You can, one, assemble the material then again yourself, which is good for the students, or you can ask the person responsible for recent trends in machine learning to give a guest lecture, which is good for the teacher because, you know, giving a lecture twice, it doesn't add a lot of time on your schedule, and it saves you the time of preparing material and mastering the material, to say.
Okay, thank you.
Timmy, I'm Varala from KKU. So can I have just, in my opinion, I have just one comment because like you have presented by the content is like focus on discussion group in this course. Is it possible if you add more case study in Crackle? Crackle is the group of machine learning for and general people interest in machine learning as well. In the data is collected, including data in machine learning is like to challenge for students to make it and discuss in Crackle. You know Crackle?
Yes, okay.
Yeah.
Yeah, I know what you're talking about, and yeah, I would definitely encourage you to contribute some labs using Kaggle data.
Yes.
Kaggle.
Kaggle. I don't know how my sound is okay.
Then immediately say do not use Kaggle, use OpenML. But for computer vision data, Kaggle might indeed be the place to go. For when we gave the seminar in Freiburg, we actually basically all the exercises were based on MNIST. So I think at that moment, or reasoning was the course already hard enough, both for us, because it took us a lot of time to, truly understand the book on such a level that we could also, be a little bit ahead of the students, and also for the students, this was a completely new topic. So, but yeah, I always think that using real world data sets, and I do not consider MNIST one of them, is something that adds something to, yeah, to a course.
I would say one more thing. I fully support what Wara is saying. And then another thing that I like to do sometimes is to gather my own data, right? And go through the full process of, gathering, removing outliers and cleaning and all that kind of stuff with the students, right? So that they see, usually a small data set. And this is apropos because I think both Jan and Wara Rad are runners, right? So one thing I did once was to collect my own running performance over a period of a few months, right? With the heart rate and the speed and the temperature and all those kind of things, and then try to do predictions and whatnot. So anyways, that's another fun way to bring in data that's kind of personalized, and you can also get students involved in collecting things. Another thing you can do is have students build a robot and have it run around in their rooms or something, gather images, right? Things like that. So there are lots and lots of things you can do to get creative with the data.
Yeah.
Yeah, one more thing from my personal experience. When I gave another course, which was on automated machine learning, but we used a lot of deep learning techniques for that. Was at the end of the course, every week I taught the students a new technique, basically, or every week we had a paper that was describing a new technique. And at the end of the course, well, students had been in touch with 13 new techniques. And then the question that they had was, so now we learned all these techniques. Why did we need to learn more techniques after the first week? And I actually thought this was a very valid question that they asked, because after they had the introduction technique, they could use random search, and afterwards, of course, we made it more complicated and more interesting and more exciting. But, that was, of course, the question, which of those techniques should we use? I think with this deep learning course, this question is very easily answered, because all the chapters, they kind of are orthogonal or different domains, right? So for the RNNs, they are being used for time series. The convolutions, they are being used for images. Basically, the practical tools, chapter 7 and 8. This is almost used for every deep learning network that you train. So I think that makes this book a very nice one, or at least this course line out a very nice one to teach. You don't really need to give the students a perspective on how does it all fit together. Are there any other points of discussions or questions or things that you would like to you would like to see? Because clearly the slides, they are already there. So yeah, there's not really something that I can do on that part to make it better without spending without running this course myself for a group of students. But those exercises, for example, I really would like to point out they are there. I now included 3 of them, but I'm pretty sure that with a little bit of pushing towards my old colleagues, I will be able to find also the other 6 sets of exercises that were there. So if there's if there's interest in that, I could try and assemble those as well.
So is there any term project in this course?
When we gave it in Freiburg, the students were just required to make the weekly exercises. and we did not hold an exam in the end. I can imagine that. So when I gave my course last year on automated machine learning, I gave the students also kind of a project to prepare them for doing research. Most of the times it was actually extremely interesting what the students came up with, but sometimes, and this is really something that I want to design for myself this year to make it more easy, the students got stuck in techniques that were being provided by the state-of-the-art papers. And you know, then when some authors publish a paper and we cannot run their code, then there's also, yeah, then they come to me and they want to ask me, hey, can you help? But sometimes, of course, sometimes I can help, but most of the times it's also, the technique is you know, except from a conceptual level, it's new for me, and I can also not execute the code or debug it anymore. And that's why I would be a little bit hesitant to start up a project that is giving the students a lot of freedom, unless there's proper support in terms of PhD students, postdocs that are in fact typically using code that go beyond, of course, the typical workbenches like Keras, TensorFlow, and PyTorch.
Yeah, I guess
But
I
that's
would,
my experience. Yeah, please go ahead.
Yeah, I would add, usually in my classes, I always have a project for right, and that the students execute in groups. And so this time that I offered this course, it was kind of interesting. About half the class chose something related to COVID, right? Maybe time series prediction or something like that, right? Trying to figure out, basically try to map epidemiological models onto neural networks and do some kind of interesting prediction. So that I think the results were not so good, right? But the students learned a lot. And then we get, I really like the ideas that they come up with. It's sometimes crazy. I have one student who has a business selling mobile phone cases. So he created some cycle GANs to actually generate artwork for his mobile phone cases, which was quite amazing. Actually, I guess the project was kind of easy, right? But I just liked it because he's thinking from a business perspective, right? And so on. And others do brain-computer interface type data analysis and things. I really love how diverse they get. But yeah, you can only do this well if you have a small class, and you can talk to them every week about how their project is going along, right? If it's less than 10 projects, it's okay, right? But if you have a big old class, then it's not gonna work very well.
So what is basically the assignment that you give them? Find a data set and do something cool with it, or do you?
Yeah, basically, yes. I mean, they have to propose, like in the first week or two of class, they have to propose something, right? And then over the first half of the semester, they usually refine the idea and then give kind of a short progress report in the class itself. So just spend a few minutes to let each of them tell what they're doing. And then, yeah, during the second half, then it gets more serious. And I try to go a little bit lighter on the assignment work and let them have more time for their project. And finally, a big presentation day at the after exams. So it's fun. The quality varies, of course. Some end up being kind of crappy, and but there's always some that are quite amazing. So.
And there's of course one big discussion that I always had with one of my teaching assistants, and then the discussion is, do they have to implement stuff from scratch, or can they use state-of-the-art stuff, and is applying it enough? And this is something that we would always get into a fight about. What is your opinion on this?
Oh yeah, I always tell them to use whatever they can find, right? So try to build on top of what's already there. But yeah, then on the plus side, it means that they can do something, they can take something that's already amazing and make it, apply it to something new. That's fun. But then sometimes it feels like they're just kind of, going through the GitHub setup page and running through the tutorial that's already there. So I have to kind of lean on them a lot to sometimes, I mean, not every group. You just have a few groups like this in a class usually. have to really lean on them to try to come up with something that is going beyond what's there on the internet, right? So use the tools, but do something on top of that.
I find it always very hard when I supervise students to assess, you know, they've gone away for a week, they come back, they show me something, and then it's very hard to assess. Did they spend a week on this, or did I do it in 2 hours, and did I just try to sell it as spending a week? And I myself have no answer to this type of thing yet.
Yeah. Well, we were all students once, and we know that miracles can be performed overnight, right? During the wee hours of the night.
Any other thing that we should discuss? Otherwise, I propose we will slowly end the discussion, and everyone has 1 hour of their life back, which might be good for some of you. I know this must have been a very intense week with doing all these sessions. I really hope that next meeting we can do it in person again, and then that would make it easier to keep my schedule free and not be flooded with with stuff that come up in Leiden, basically.
Yeah. Can we go around a little bit and ask people to speak up? Like, OPIM, we haven't heard from you.
We can still not hear you, by the way. I don't know if your mic is open.
It's late.
It's late? Did somebody?
I think the mic is malfunctioning, given that
Okay.
yes,
Okay.
you unmuted.
Next time, maybe? Anyone else want to ask? Erna. No, we can't hear you.
Muted the system.
Coba, try.
Anyone else? Maybe.
Excuse me. This slide you said that teach students how to map from formal notation to code. You check and correct. You correct student by code only, or you how to evaluate your student.
So basically, in my courses, I give 2 serious courses every year, and the 3rd course is well, it's just you know, keeping the students busy. But in the first year students, the first year bachelor students, they hand in code, and we go by the code line by line. Actually, not me myself, but the teaching assistants do this, and they give very detailed code feedback. The master course that I gave, and also when we gave this foundation of machine learning course, we cannot. There are so many ways to solve a certain problem, and we cannot even, you know, do unit testing. So when I give the algorithms course to the first year bachelor, I say this is the expected input, this is the expected output. If the output doesn't match what we expect, please do it again. For courses like this, it's impossible. So myself, I haven't really solved how to efficiently and how to without burning through lots of hours from the teaching assistants, how to assess the quality of the homework. And at the moment, what we do is we run the code, and you know, if it doesn't work, then if it doesn't crash, then it works. Basically, is what we say. So that's a very limited way of checking. For the course that I gave last year, I tried to make some assignments for the students that actually were testable. So I specified the input and I specified the output that I expected from them. And well, we could just unit test the output. This is all on the topic of automated machine learning. So it would partly be in scope for this course. I could actually also attach this exercise. The annoying thing from this was, it costed me a lot of time to specify the assignment in such a way that unambiguously, you know, the student knew what they had to do. That this was a crazy amount of work. And second of all, if in terms of, in this case, automated machine learning, but the same with deep learning, if you want to, you know, remove all degrees of freedom and you want to specify input output in order to be able to unit test things, there's not a lot of interesting things you can actually ask the students to do, because all the interesting things you have to do behind the screens to ensure that all randomness and all things that can actually vary if you don't specify it correctly, you have to basically give it away to the students. And this is what I find very, very tough on this part. So basically, when we gave the course in Freiburg, we just didn't check it. What I think was the main takeaway, well, we run it, but we didn't really check it. What I think was the main giveaway from the students, when I myself read a new paper, I'm always, you know, and the math looks impressive, I'm always trying to think myself, how would I code this up? Which SciPy function do I need, you know, to implement this in as few as possible lines and with as least as possible effort? And by giving the students these notebooks, basically, we teach them this, right? We are not asking them for something extremely complicated, but we just tell them, look, this is what the book looks like, and the math looks incredibly complex, but if you implement this, it's only this stupid function that will bring you there in 5 lines usually. And I think that's the main value of the exercises, and well, that they eventually, you know, have maybe somewhere some problems still in there. Well, that's it's also a little bit up to them to learn something from it, I think.
So you provide resource for them, or student responsibility to individual laptop or some kind like that? You provide server for them?
Yeah, in Leiden. So in Freiburg, so all the assignments that are being run, that are attached currently to the exercises that I put together with the slides that I stole from the internet, these can be run on a personal computer. There's nothing that requires crazy amount of computation. So there's that. In Leiden, I know that the course is being given, and sometimes people have to do things on ImageNet. And then, of course, you cannot do things on your own computer. And we do have some servers available for this. However, I think this infrastructure is also, well, it doesn't really scale, right? Because there's always more need for computation time than computation time. And what I actually think a perfect exercise or a perfect thing for students to learn, they can run it, and within a minute they know whether they failed or whether they succeeded. And when you start moving things to clusters, I think your problem is you have to set it up, you have to schedule it, you have to wait maybe, if you're lucky, for a minute, if you're unlucky, for an hour, and then it's going to do complicated things. But this gives you only, if you can do this once a day, this only gives you 7 iterations before your next lecture starts. Whereas if things could be done on your, if the assignment is easy and simple enough to be done on your laptop, you can, run, test, fail, run, test, fail. You can keep on doing this until it works. And I think this is how the ideal exercise actually looks like, especially for students if they need to learn something that they, well, the goal is to learn, right? The goal is not for them to do some groundbreaking research yet. So at least that's my opinion on this topic. Does it a little bit answer your question, or did I go into a direction that?
Yes. So in your opinion, when you assign the example for students, so assign assignment to do homework, some kind like that. You give the same case study or different case study. It means if you give the some case study is the same for all students. So
All the same, yeah.
all student,
In
all
fact, I
student,
give.
yeah.
Yeah. So
Okay.
in fact,
You
this-
evaluate them for highest accuracy or you freedom to presentation? No.
Yeah.
That's
So when we gave this course, accuracy was not something. Of course, when you do neural networks, your goal is to have as high as possible accuracy. And of course, it will for a student be fulfilling if the accuracy goes up and the error rate goes down. But there are so many things that so many nitty-gritty details that you can actually have wrong when doing this exercise. That some students, they might, push MNIST to 97% if they don't use the proper convolutions, and others they will stick somewhere with 92%. And it's not really something that's I feel if I want to punish the persons that have a 92%, you need to be able to say, okay, this is what you did wrong, and this is what you should have improved. And since the code is getting so complicated, I do not dare to ask my teaching assistants on turn, to go into this level of detail. And therefore, when we run the course in Freiburg, all we did was check if there's no errors when you run the notebook. And of course, the students had the liberty to ask questions when they, when they got stuck on something. But we did not really check their solutions into detail for reasons of time and complexity.
Mm-hmm. Okay.
I could have done that, for one or two student pairs, but after that, there's also other things that you need to do in the week, like giving other courses, or in my case at that moment, I had to do research. So I think the complicated part is, so basically one thing that what I did for my course last year, I did check for plagiarism. So we have this tool that we can upload all the code from all the students online, and then we can see if students work together. And well, in case that two solutions look enough similar, then of course they have to come and they have to explain themselves. But that's basically all the checks that we did on it.
Okay, thank you.
Any other? I realized that my teaching director is also in this call, so for my next evaluation call,
Okay.
I will get a stern word maybe from him. Any other question from any other person?
How about Ruan? We see you lurking.
Oh, yeah.
Can you hear me?
Yes.
Yes.
So
For us to choose
the type of data that we can use.
for the student, right?
For example, we can
Concentrate
on the quantity of data,
Putus-putus
or
Ali.
we can
on the
concentrate
algorithm.
So it is for us to choose, right?
Yeah, well, I personally, I think that's my of course, it's always for you to choose. Let's start with that. But when we gave the course in Freiburg, we focused completely on the algorithmic part. And this was kind of proven by the fact that students always did things on MNIST, and MNIST is not such an interesting data set. I think there's also, there's other data sets that might be more interesting. that can make it more complicated to the students. But maybe the way of cleaning and pre-processing this data requires techniques that do not really fall within the scope of deep learning. Of course, this is not necessarily a deep learning course. This is called, how do you call it? Recent trends in machine learning. Yeah, so it could go any direction you want, of course. Although, maybe this is a little bit an opinion that I took with me from Freiburg, but focusing on the data part, everything that you do with data is a little bit, you know, it might be intuition based, and everything that you do on the algorithmic part, this is very much more scientific based. So this might be, in my opinion, the better way the better side to focus on. But that's of course heavily opinionized by me, and of course by the people that back in the days or still influence me. Yeah, what is your opinion?
Yeah, I think so. Also, we can choose algorithm directions. Yeah, or after they master the algorithm, okay, so they can especially, okay, so they can okay, change the light, etc.
Sorry, I had some problems hearing the complete sentence. Every now and then it dropped.
Internet connection is not very good. The mic is like that.
I think we cannot hear you, right? Yeah.
Do you hear me? Right?
Now I hear you. Yes.
No.
Yeah.
Yes.
Uh,
Uh-oh.
how we can rhythm, right?
Sorry, I cannot. I by no means want to cut you out of the discussion, but I cannot really hear the full sentence. So maybe you can put it in the chat. Do we have a chat somewhere?
Yeah, we do. Okay.
At least hear some typing. Maybe in the meantime, are there any other discussion points? And then in the meantime, Opum can put his opinion in the chat, or his contribution. Yeah, so Opum writes, I think we should concentrate more on how the students mastering the algorithm, and after they can choose some real data to work with. I think that's the setup that Matt also chose in his course, where they, at least that's how I interpret what he just said.
Yeah, I think we agree, right? Open. Are you? You want to ask anything? What's your opinion? How about Mahasen? Who's that? Very shy.
Oh my.
Looks like Marcello also got dropped, right? Or had to leave.
I think since it's 2:15, that a new slot in his calendar might have
Okay.
appeared.
Well, maybe if there are no more comments, we should close the session, right? Anyone have any more issues to discuss? This is your, well, not your last chance, hopefully, to talk to Jan, but anyway, you've got him. He's obligated to stay with us for at least 45 more minutes if you have anything for him.
Okay, thank you.
This is, Matt says, absolutely not your last chance to interact with me. And yeah, well, I hope that during the next project meeting we can discuss also, well, more things that people encountered when going through the material. And
Yes, I hope we can see face to face next time.
Yes.
that would be magnificent. Yes.
Maybe in Indonesia.
Yes.
Yes, you're welcome. You're all welcome.
Very good.
Sure.
I want to ask one question. What do you think about the explainable AI? Why don't you inside that?
I think this is I actually have a good friend that wrote also a publicly available book on this. I'm not super aware of the techniques and the state of the art in explainable AI. But clearly this is going to become more and more important over the coming years when decision making is being outsourced to computers. And the computer saying yes or no to whatever question, then we should also figure out why is the answer being yes or the answer being no. And I think it's very related to also something that I would call fair AI, or I think this is also something that is going to become way more important. I think it's also very related to the topics in this course, because one could argue that when you do vanilla machine learning, let's say the first course in this curriculum, then you know, you learn about linear regression, you learn about the decision tree, and everything is kind of explains itself. Whether it's still fair, this is of course a second point of this discussion, but the moment when you move to deep learning, you really need to ask yourself the question: why is the computer why is the model giving me this decision? And yeah, I completely agree that it's a super important topic that could that has focus in this course. Currently, there's no, it's not being discussed, but or not being covered. But this is of course something that could be covered by students in their free space of this course, or of course also the teachers have a lot of freedom to add. Yeah, to add content in things that are not defined yet, or things that are not defined. There's of course, so this was basically the first thing when I looked through the outline. If I were to give this course, I really like the outline, but I would probably drop some topics to make room for a little bit more automated machine learning, or I would and I think there's a lot of room currently in this yeah, curriculum to do to swap out some topics for other stuff.
Yeah, I guess I would add that. Go ahead. Sorry, I didn't mean to interrupt.
No, I was done.
Okay. Yeah, I would just add that I suppose this trend in explainable AI is one way in which we can reach out to industry more, because yeah, usually academics don't care too much if their model is explainable or not, right? We just want to do something new. We want to get better results than people have gotten in the past, and don't pay much attention. But this has always been a problem in industry. I used in the 90s, I worked for one of the companies that brought automated neural network based fraud detection to the credit card industry for the very first time. And this was a huge thing that if their automated system rejected someone's credit card transaction, there had to be an explanation of why, right? Otherwise they would be in legal trouble, especially if there was any racial or gender or any kind of bias in the decision somehow, right? So the companies have been trying to figure out how to do this for decades, and I suppose not. I mean, they have plenty of tricks and techniques that they use, but it would be wonderful if there's a more theoretical foundation for all this stuff. So this is where we could really make a difference for industry.
What I find very hard about explainable, or sometimes you review a paper, of course, and someone says, well, we didn't reach state-of-the-art performance, but we are explainable. I find it something very hard to measure. It's something very easy to claim, but very hard to measure if you're not a domain scientist on the field that it's being, and that's probably the reason that science hasn't picked up on the world topic as much as we would expect.
That is a trick I hadn't thought of, though. It's a way to get published with a suboptimal result, right?
So anyone we didn't hear yet? Punyapul, do I pronounce it correct? Anything to add?
Banyapon, you want to?
Yes, I just coming.
Okay.
I just come.
Would you like to ask any question before we close the session?
I just come, but
yeah, we're winding down. But if you have any more discussion, we'd be happy to entertain.
I would like to know the previous mentions about the topic that you discussed. But I just coming, and I am sorry.
Okay. Well, the session is recorded, so you can certainly access in the VLE. We'll post all the recordings of all the sessions.
Okay, if there's no more points of discussion or questions, then let's close this session, and I hope to see you all very soon. And please feel free to reach out if there's any question in particular about the exercises. This is something that I try to add to the outline, but well, also other questions, please feel free to reach out.
Thank you.
Okay, thank you very much.
Thank you, Jen.
Okay.
Thank you.
Thank you all.